polar coordinates. This is very similar to the rectangular coordinate system. Let's just do a quick review of the rectangular coordinate system. In fact, I have a blank XY. And if you remember, this is the x-axis and this is the y-axis. If you take a point, that'd be x comma y. And if you go right and up, that's positive. Left and down is negative. Now, if I do take this point, well, before I do that, we're now going to be talking about the polar coordinate system. In the polar coordinate system, is going to be of the form, the points will be r comma theta. R comma theta. And some definitions here. We have the pole, which is called the origin. The polar axis is the positive x-axis. So I'll go back to my blank xy. This is now the polar axis. The positive x-axis is, and the origin is called the pole. So that's how they differ a little bit. I'm going to erase that because I want to use this again later on. But the main thing is that it's r comma theta, and now we're going to plot some points, or a point. But before we do that, there's something that you really need to see. If you remember or seen my other videos, you see me do this quite a bit. I'm drawing a right triangle using a point. This is my x side, and this is my y side. This is going to be my r. Since it is a right triangle, I can use the Pythagorean Theorem, which states that r squared equals x squared plus y squared. This is a very important item that you want to use and know, memorize. Now, if I take the square root of both sides, I get r equals the square root of x squared plus y squared. So this is going to be very, very important, what we're about to do. So, the reason why we need to do that is because instead of using x comma y in the polar coordinate system, we're going to use r comma theta. Theta is the angle, r is magnitude. It's actually distance on the terminal side of the angle. So let's do an example. We're actually going to plot -2 comma 150 degrees in polar coordinates. -2, 150. So -2, 150 degrees. Now recall what I just said. -2 is our r, 150 degrees is our theta, our angle. So what I want to do first, I actually want to draw the angle first. So 150 degrees, I'm going to start on this polar axis first. And 150 degrees is about right there because it's 30 away from the 180 degrees. So my angle, this is my initial side. This is my terminal side. This is my 150 degree angle. Now I need to graph or draw the r. Now, if it were a positive r, I would draw it on or mark it off on the terminal side. But since it isn't positive, if it's positive, I put it over here. But since it's negative, I'm going to put it on the other side. So I'll mark up two places somewhere. It doesn't really matter where. I'm not too concerned about that. My main focus is that it's going to be on this side of the terminal side. So I have to extend it because of that -2. So it actually puts it in the fourth quadrant. So that is -2 comma 150 degrees. So it's like you draw a 150 degree angle. If it's positive, I'll mark it on this terminal side. If it's not, I extend it and mark it on the opposite side. So positive is on terminal side. Negative is on extended opposite side of terminal. Something like that. Now I can also state or label this point another way, other ways. In fact, there's an infinite number of ways if we keep on going around the circle in either direction. So what I want to do this time, I want to go this direction, which means that our theta, instead of being 150 degrees that way, because that's counterclockwise, if I go clockwise, I'm now in the negative. And that's going to put it at negative 30 degrees. Negative 30. Because I'm actually just 30 degrees away from the x-axis here. So I'm going to be 30 degrees away from the x-axis here, but I'm going clockwise, which makes it negative 30. So that means that my angle is negative 30 degrees. But watch this. If I draw a negative 30 degrees, let me use a red pen. Hopefully you can see that. So it looks like this. So this is my theta, my red theta, which is negative 30 degrees. But now this time the number is on that terminal side. So instead of it being on the opposite side, it's staying on the terminal side, which makes it a positive 2. So in that case, it's also 2 comma negative 30 degrees. So if it's positive, it stays on the initial side. If it's negative, it goes on the terminal side, and if it's negative, it goes on the extended opposite side of the terminal. So pay attention to that. And if we go around, say we were restricted from 2 pi to 4 pi, which is 360 degrees to 720 degrees. If I go counterclockwise, that's going to put us 30 degrees less than 720, which would be 609 degrees. Well, actually be not that, because I'm actually going to be up here. It'd be negative 690 if I go that way. So it's actually not 690. Well, yes it is, because I'm going counterclockwise. So it does put it at 690. So I could say it's 2 comma 690 degrees. That's another way to write it. Or I could write it 2 comma 330 degrees. So there's several ways I can write it. Or negative 2 comma, if I go around twice, so that's going to be 360 plus 150 more, 510. So it could be negative 2 comma 510. So there's more than one way, in other words. But here is probably some of the most important information you need to know. We're going to be converting from polar coordinates to rectangular coordinates, so it's r comma theta to x comma y. And what we're primarily going to use is information that we already know. We know some trig functions, trig formulas, trig identities. We know that sine theta is the same as y over r. If you multiply both sides by r, you get y equals r sine theta. And I'll show you that, because you may forget that. So if you better know this already. So if I multiply both sides by r, that's how I get y equals r sine theta. The same thing is true with x equals the r cosine theta. So these are the two main items you need to know. And then we're also going to go the other direction, from x comma y to r comma theta. In that case, you're going to be given x comma y, and we can use x squared plus y squared equals r squared, which is better used as r equals the square root of x squared plus y squared. That's what we really want to use. And once again, I'm just taking the square root of both sides, ignoring the minus. And then for find theta, since I'm given x and y, I want to use the inverse tangent to find my theta. So I'm using tangent theta equals y over x. So theta is going to be inverse tangent of y over x. So just using things that we already know and just manipulating them a little bit. And then we can also use your calculator. But I want to do it by hand. Do a couple of examples. First one I'm going to do by hand. Second one I really can't, because these aren't nice angles. Okay, so find the rectangular coordinates of the polar point. This is a polar point, which means this is in the form r comma theta. That's very, very important. And these are in radians. So if it were me, I want to do it by hand. I prefer to think of 3 pi halves as 270 degrees, assuming you don't have a unit circle. but this is just the way I like to do it. And the way I get that is, if I'm convert to degrees, that times about 180 over pi. The pi is cancelled. 2 goes in 80, 90 times, 180, 90 times, and 90 times 3 is 270. But in any case, I'm going to use x equals r cosine theta. I want to use y equals r sine theta. Now, the only reason why I'm doing it like this, 270 degrees, because I know the unit circle in my mind. And I know that 270 degrees is down here. And the point on my unit circle, that's 0, negative 1. So what I'm doing is I'm going to take 4, or r, which is 4. See that? R is 4. And then cosine of 270 degrees, or 3 pi halves, either one. And we get 4 times, well, cosine 270 is the x value, so that's 0 at 270, which is 0. Then do again for y. So y equals r, which is 4, sine 270 degrees. 270 y value, because sine is y value, is negative 1, so it's going to be 4 times negative 1, which is negative 4. So 4 comma 3 pi halves is the same as 0 comma negative 4. And that's the answer. Now let's look at our calculator and see what it can do for us. Now if I decide I want to keep it in radians, I want to make sure my mode is in radians. So it is. If I use 270 degrees, I'm going to use degree. So what I can do is, if I look at second apse, in this case, which is the angle, you'll see that r to the p, that's rectangular to polar finding the r. It's the rectangular to polar finding the angle theta. But 7 is from polar to rectangular finding the x. And I like to go up. 8 is polar to rectangular finding the y. So what I want to do is I want to find the x first. So I'm going to hit that. I'm going to type in 4 comma 3 pi divided by 2. And we get 0. Then I'm going to hit, I like to hit second enter. I probably don't need to do that. Some people might not like that. Let's hit second angle. And then 8 will give me the y value. So let's hit 8. 4 comma 3 pi divided by 2. Oh, made a mistake somewhere. I didn't do my 2. And you see the negative 4. So your calculator will do it for you. But you'll find out you'll want to do it like this, and you'll want to use your unit circle if one is provided to you. Maybe in pi halves, there's 3 pi halves. Because a lot of times your answer, if you look at your unit circle, isn't going to be nice numbers. It's going to be radicals. So a lot of times it's going to ask for specific or exact answers in radical form. So be aware of that. Now this one, we have ugly numbers. So in this case, I'm not going to convert it to degrees or anything. I don't want to, because they're ugly. They're not nice angles. So this is still r comma theta. So it's a bad theta, bad angle. Not bad, it's just not one that I recognize. Now, anytime you don't see a degree mark, the theta is in radians. If you haven't been aware of that, you should be now. So I'm still just going to use x equals r cosine theta. And this is actually going to be really easy, in case you're wondering. This is going to be easier than doing it with the calculator feature. Because this one, all I do is take the r, which is 8.1, cosine 5.2, and then 8.1 sine 5.2. And that's fine. Let's take those two values, those two expressions we have. Make sure we're in radian mode still. And we just type in 8.1 Here's how easy it is. Cosine 5.2 and we'll hit enter and we get, let's just round to two places, 3.79, and then I'm just going to hit second enter and I'm just going to move it over and hit sine because that's something that changes for the from x to y. We get negative 7.16, and that's our rectangular form. 3.79 comma negative 7.16. That's all we're doing. Now we're going to go the other direction. This time you're asked to find r comma theta, and we're given x comma y. So we know that x is equal to 0 and y is equal to 2. So we need two things. We need r and theta. So when I find r, I use the square root of x squared plus y squared, which is the square root where x is 0 and y is 2. Let's just go up here. So we have r equals square root of 0 plus 4, which means r is equal to square root of 4. R equals 2. So we have a r. Now we need theta. Now if I plot this point 0, 2, it's going to put it up here on my xy plane. So I pretty much know it's going to be on my positive x-axis, and I already know what that angle is, but in case that it's not there, it's one you may not recognize, here's what we're going to use. We're going to use tangent theta is equal to y over x, because we're given x and y, so we can use tangent. So tangent of theta is equal to 2 over 0, and that's not possible. So we have to ask yourself, where does tangent not possible? Well, there's two places. On the positive y-axis and on the negative x or negative y-axis, and you know that because tangent's y over 0 or y over x. 1 over 0 is impossible to do, so we have one there and one there. But since we plotted the point here, our theta, or our angle, is going to be 90 degrees or pi halves. So we're going to use pi halves. And that's our other part of the point that we need. So that means that in polar form, it equals 2 comma pi halves. It really isn't that bad, to be honest about it. Now this one, once again, is in x comma y form. This one, it just doesn't look too good. By the way, before I do that one, let's do this one, just to show you something. Well, what I was going to show you was, if you go back to your calculator, you can actually look at under a second angle, and you'll see r to polar, finding the r to polar, rectangular polar, finding the theta. Let's just go ahead and do it. You want to? Can't hurt anything. Zero comma 2. So I'm going to hit 5. 0 comma 2 close. Now the mode doesn't matter what I'm in for my r, because I get the 2. But if I hit second angle, I want to find the radian portion, rectangular to polar, find the theta. If I type in 0 comma 2, let's see what mode we're in. Still in radian mode. I get that ugly. decimal. What happens if I do this? If I do mode degree and then find it, you see I get 90 degrees. And what is 90 degrees the same as? Pi halves. So, something to keep in mind. Well, yeah, if I need it, I'll come back to it. Let's do this one. For this example, once again, we need to find r, comma theta. So to find r, let's just go straight to the square root of x squared plus y squared. And x is negative 2.3 squared, and y is 0.2 squared. And let's just take out our calculator and type that in. I'm going to type it in all at once. So second square root, then another parentheses, so I have two parentheses beginning, negative 2.3 close squared plus parentheses 0.2 close squared, and then close again, and we get, looks like 2.31. I'm going to move this over. Now for my theta, I'm just going to go, instead of doing this because it's not a nice angle, so I don't want to think about it too much, I'm just going to go straight to theta equals inverse tangent of y over x. And we're told, or given, y is 0.2 and x is negative 2.3. So let's take out our calculator and let's find inverse tangent, second tangent, and then 0.2 divided by negative 2.3, close, enter. And now I get theta equals negative 0.087. I'm doing everything in terms of decimals, and I'm doing everything in terms of radians because there was no degree symbol given. Well, not worry about degree symbol because this is x comma y. But I want to do everything in terms of radians because, for one thing, the angle is messy no matter what. And so just keep it in terms of radians. But now we got to think about this for a second. The original point is negative 2.3, which would be to the left, and then 0.2, which is up. So it's actually going to be over here in the second quadrant. So we need a second quadrant angle. This angle isn't a second quadrant angle. And there's lots of reasons why we know that. One reason is that inverse tangent is from negative pi halves to pi halves. So either the first or the fourth quadrant. Something else, negative 0.087. Well, negative pi halves, let's just show you what negative pi halves actually is. Negative second pi divided by 2 is negative 1.57. So if that's negative 1.57, and we found negative 0.087, that means that this is somewhere in this region. So this is a fourth quadrant angle. We need the second quadrant angle. Well, what do we know about how to find that? Well, we know first off this is negative 0.087. 0.087 is the reference. So we know that it's going to be, it doesn't matter if it goes to the point or not, but this is going to be 0.087 in the second quadrant. So what that means is that we need to take that reference angle from pi, because if you look at your unit circle, that's pi. So our actual theta is going to be or in other words, our second degree angle is going to be pi minus 0.087. And that's going to leave us, let's take out our calculator. Second pi minus 0.087. We get 3.05. So that means that in our r comma theta form is 2.31 comma 3.05. Now we're going to do some substitutions. We're primarily going to be using the same things we've been using. And we want to go to polar form to convert to a polar equation, which just means it's going to have nothing but r's and thetas in it. So let's start with what we're given. And we're going to do substitutions. So let's think about this for a second. What do we know about x if we want to use r's and thetas? Well, based on what I put or mentioned before, we know that x is equal to the same as r cosine theta, and y is the same as r sine theta, which I have it right there also. So I really need to write it again, but it doesn't hurt. So what I want to do is use x is r cosine theta, and then y is r sine theta. And then we're just going to clean this up a little bit, because we've already have gotten rid of the x's and y's. So we just want to simplify it just a little bit. One thing I can do is this exponent 2 it's on each of these, so it's on each base. It's on r squared, and it's also on cosine squared. And this is the same as 8r sine theta. And what I can do here, I can actually divide both sides by r to have fewer r's roaming around. So I have r cosine squared theta equals 8 sine theta. And then from here, I want to move it up here because I'm out of room. But if I want to solve for r, I just divide both sides by cosine squared theta. We have a polar equation. So we're going to try to simplify as much as we possibly can. Now let's use one where we're given polar form. We want to go to rectangular equation form, which involves x's and y's. So what do we know about r? What do we know about sine theta? So one thing you may want to do, you may want to keep r as it is for now. And sine theta, what's sine theta the same thing as? Same as y over r, isn't it? And a trick we may have to do, we may need to get rid of fractions. So what I'm going to do is multiply by the LCD, which is r. So I'm going to multiply each one of these by r. And the whole purpose of doing that is so these will cancel. And it leaves r squared equals 1 plus r. And what do we know about r squared? Well, it's the same thing as x squared plus y squared. Y, we want to keep it as y because we're trying to keep it all in x's and y's. And the r is the same as square root of x squared plus y squared. And since we have it all in terms of x's and y's, we're done.